So we're going to be looking at problem solving where you know all the details.
These students are developing their questioning skills to support them in solving mathematical problems. Here they've been given a problem with all the necessary information. Each student needs to ask him or herself questions which they believe will help them solve the problem, and then compare their questions with those of the other students.
A couple of minutes to think by yourself, and then see if you have any questions. So the second session was a piece of paper that had a strip torn off, and then we started folding over into 45-degree isosceles triangles, and we were using a lot of work manipulating surds. And we needed to find the area and perimeter of the new shape once we'd folded certain sections. It was much more about applying a process to solving consecutive small problems, but doing it accurately. So it was the cross-checking with each other, stage by stage, that got us towards a final answer for both the area and the perimeter. What's the next thing we need to worry about?
A fold.
Yeah.
Yeah, it folds.
How does that fold work?
There's going to be a 45-degree angle in the bottom left-hand corner.
In that sense, they were developing team-working skills. I think there was a group of 3 of them that were working together quite solidly. They were actually justifying each other's work to one another, which meant that there was much more chance of getting to the accurate solution at the end.
I think working together was certainly just reconfirming what you were hoping the answer was going to be with somebody else.
Now you have to square root the whole of that and it will give you the length of the line. So square root all of that gives you the length of the hypotenuse. But I don't know how you would do that.
If a teacher told you it, you'd maybe forget it and then learn it again in a textbook. But if you've been corrected by like a fellow student or you've worked it out yourself, you'll remember it and you'll see the question and go, oh, I got this wrong last time, but so-and-so gave me the right answer and I remember how to do that.
You know that length is equal to that length.
So we know what
A.
we now know what this length here then is, don't we?
No.
C squared.
Why do you
It's
think?
just
Well, you do. It's root 2 minus root 2 over root 3.
Yeah. So it was slightly more straightforward in that there weren't questions demanded of me, but there was a lot of questioning of their own surd manipulation capability. So they were working together to solve those particular problems.
I think there was definitely a lack of confidence with the first one, and I think with the second one that confidence grew, having not only done the first problem, but having that tiny bit more information there, because it was almost a reassurance that there was information and your sort of thinking process was actually the right one.
Well, I was quite pleased with the alacrity that they took to the problem because they could see it was definitely feasible to work your way through it.
this I already know. That I know, that I know. I'm working out this, and then I can finish working out that.
We already had a vague grasp on what we were meant to do, so we just sort of got on with it and asked the teacher if we were on the right lines. It's sort of like this problem-solving idea. It's sort of very similar to some of the questions I've got in other maths tests. So it's not really, you don't just use it in this topic, you can use it in the maths test or a further maths test, where the questions aren't going to be as obvious as you would hope them to be.
With this, I had to look at it and pick out 3 or 4 different things that I could use and then find the actual process that I would have to use from the start and follow it through.
I think what this has shown that actually there are elements of maths in which you have to bring together, such as surds and Pythagoras. So no, I feel that confidence was boosted in the second one.
It was a relatively simple question that had a high reward in terms of the amount of practice that students got involved in, because you got obviously both the area and the perimeter to worry about calculating, but the number of surd calculations you put in there, it replaces sort of almost a textbook's worth of questions just in that one exercise.